Turn off the lights with me. Feel the hush of a dark room, the held breath, the quiet between heartbeats. In that hush, a human question: when physics says nothing, what exactly is being subtracted? Is it matter? Light? Fields? Or even the stage itself, space and time? Tonight, we'll audit the books of reality and ask which ledger the universe actually uses for zero. Let's start with a thought experiment. We seal an ideal box. We remove every particle and every photon, we cool it to almost absolute zero, and we isolate it from the world. Place it on a perfect scale. Should the dial read exactly zero energy? If not, what is still there? Here is the map we've made so far, the fastest tour of nothing we can responsibly take. In modern physics, emptiness is not the absence of stuff, it is the ground state of fields. Think of a field not as a thing with edges, but as an invisible ocean that fills every point of space. A particle is just a ripple on that ocean. What we call the vacuum is the ocean at its calmest. Yet even the calmest ocean has texture. Zero-point energy is the irreducible jiggle you can't squeeze out of the vacuum. In quantum mechanics, uncertainty forbids total stillness the way language forbids a sentence with no vowels. We see its fingerprints. The lambs shift. The electron in hydrogen is nudged by the vacuum's restless whisper, shifting the atom's energy levels. The Casimir effect. Two metal plates placed closely together are pulled together, as if the vacuum between them lost a note from its symphony, and the outside pushed harder. Some fields hum even in silence. The Higgs field has a non-zero baseline, like air that's thick with syrup, so when particles move, they drag through it and acquire mass. Vacuum expectation value sounds like bureaucraties. It's really a standing low tide that reshapes every wave that crosses it. And vacuum energy gravitates. In general relativity, energy and pressure bend spacetime itself. A uniform vacuum energy acts like an anti-gravity pressure, dark energy, pushing the universe to expand faster and faster. Tiny vacuum jitters may have painted the largest structures we see. During inflation, if the early universe ballooned by a stupendous factor, microscopic fluctuations were stretched to cosmic size, seeding galaxies and clusters. The baby ripples became the bones of the cosmos. Even vacuum depends on who you are and how you move. Accelerate hard enough and empty space feels warm. This is the Unruh effect. Near a black hole, horizons bend what counts as nothing. To a distant observer, the horizon radiates. To a falling observer, nothing special happens at that very moment. Along the way, a few translations. Virtual particles aren't literal pop-in pop-out gremlins. There are shorthand for the vacuum's allowed fluctuations when we do our calculations, a story we tell to track how the ocean sloshes. And zero in quantum field theory is like sea level on a nautical chart. You can slide the whole map up or down, and the tides still work. Only differences matter. Except gravity. Gravity cares about the absolute sea level. Now we slow down, because the ledger doesn't balance. If we estimate the vacuum energy by adding up all the zero-point jiggles of every field, naively, we get a number so huge it could erase the universe in an instant. What we observe as dark energy is smaller, by a factor of about 10 to the power of 120. That's the cosmological constant problem, the greatest mismatch between theory and measurement in all of science. Renormalization is our fix-it kit. It's like declaring sea level at a tide gauge and measuring everything relative to it, subtracting infinities to get finite predictions that match experiments with absurd precision. But what chooses the true sea level that gravity reads? We can tune a constant to fit the cosmos, but we don't yet know the physical principle that sets it. Then there's the possibility of many vacua. Fields can have multiple resting places, valleys separated by hills. We might live in a false vacuum, a local minimum that looks stable for longer than the age of the universe. In principle, a bubble could nucleate and roll the field to a deeper valley, rewriting the laws of physics at the bubble's edge. That's a cosmic version of ice suddenly deciding to melt, not because it warmed, but because the landscape changed under it. All of this usually assumes a background stage, spacetime. But several paths to quantum gravity whisper that the stage itself might be woven from relationships, entanglement links, informational patterns, holographic codes. If the play creates the stage, what is a vacuum? In the usual sense, energy is defined by time translation symmetry, If the laws look the same from one moment to the next, Noether's theorem hands us a conserved energy. But if time itself is emergent, the yardstick we use to measure energy is born inside the system, not given from outside. What does nothing mean when even the ruler is drawn on the same paper we're trying to erase? Let's audit the horizon. An inertial observer floats by, thermometer reading absolute zero. An accelerating observer, racing her, reads a warm bath. Both insist they've done the math right. Whose zero is the real zero? The answer may be that nothing is not a single line item but a context, like silence for a bat and silence for a fish. And a final caution, the philosophical nothing, no space, no time, no laws, is not the physicist's vacuum. Some origin stories, like tunneling from nothing or no boundary cosmologies, use nothing to mean a law-governed state with no classical boundary, a kind of rounded-off beginning. That is not an absolute void, it is a different kind of something, with rules but without edges. So what does all of this mean for us? First, emptiness reframed. The best nothing we know is a well of possibility, not absence, a silence charged with capacity, like a canvas primed to take paint. Second, humility in accounting. Our largest error bar sits on the line marked 0. When your uncertainty peaks at the baseline, the universe is telling you where your model bends. Third, emergence and relation. If space-time and fields crystallize out of patterns of information, then nothing may be the limit of relation, not the limit of substance, the moment you can no longer draw a connection, rather than the moment you run out of stuff. On the human scale, the pause before a word, the stillness before action, the blank page before a poem, these are not wasted, they are formative. Precision about what we know, and what we do not, isn't cold, it is a form of care. All becomes a method, not just a feeling. Synthesis. We asked how nothing can have properties. We learned that the vacuum is an active ground state of fields, jittering with zero-point motion, shaped by non-zero baselines like the Higgs, and heavy enough to bend the cosmos. We saw where the model phrase, a 10-120-fold mismatch, many possible vacua, and the hint that space and time might be born from deeper relations. In our audit, zero is not empty, it's the most crowded idea we have. A contemplative takeaway. Tonight, sit for 1 minute in a quiet room. Notice the urge to fill the silence. Then imagine that silence as the vacuum, brimming with invisible structure, setting the stage for what comes next. What would change in your work, your art, your love, if you treated your pauses not as gaps to be feared but as charged vacua, places where structure can be seated? The next great question. If nothing already contains the rules that give rise to everything, where do those rules come from? And if time itself is part of the story the universe tells about itself, if time is an illusion, what does that say about the memories we hold most dear? Our audit continues, exactly where the books don't yet close.